let's discuss the date and time classes that were introduced in Java 8. All of these classes are part of the java.time package, which you can open up the API page for that. There's actually quite a lot of information and some good examples on the main page of that API, so I encourage you to take a look at that. And of course, there's also all of the actual classes listed and the enums, and the descriptions in this API are particularly useful, and there is a lot of good examples. So I definitely encourage you to take a look at the API page as you begin to learn how to use these classes. So why are there new date and time classes that were introduced in Java 8? Well, the old ones were really inadequate, and there were a lot of reasons for that. They weren't thread safe, but they also were just pretty poorly designed, and this was spoken by the people who designed them. There wasn't a lot of consistency, and there were some strange things. So, for example, the months began being numbered at 1, the days started at 0, and there were other inconsistencies. So the release of the new java.time package, new as of Java 8, was meant to address all these deficiencies. And personally, I think it does a great job of doing that. It's very user-friendly, and once you kind of get the hang of how all the classes are set up and how they interact together, it's very, very user-friendly to use these classes, much more so than the old date and time classes. So all of the old date and time classes have been deprecated. You shouldn't be using them anymore. You should definitely be using all of the classes in the java.time package. They are designed to be clear and intuitive. I think that they are. They are also thread safe. Now, one last thing that's very important to know about the classes in this package is that most of them are immutable. Remember what immutable means. It means you cannot change an object once it's been created. So what that means is you can create new instances based on existing objects, but you can't change an object. So there will be some consistent method naming that allows us to create new instances. Those methods will start with of or from or with, and we're going to look at lots of examples. But there's no constructors and there's no setters in these classes for the most part. No setters because they're immutable, and no constructors because instead we have these sort of factory style methods to create instances of whatever object we're using. Hopefully this is going to become clear as we start looking at some actual examples. Let's talk for a moment about what immutable means. So again, most of the objects in the java.time package are immutable. What that means is that you can't change them by invoking a method. What you can do is you can create a new object and then reassign it to that same variable. That you can do. But that is different from changing the object. This is the same as strings. Strings are another example of an immutable class. So for example, if I had a string name whose value was Jessica, if I just invoked name.toUppercase, this will return a new string, Jessica in all caps. But then I don't do anything with that return value. It's just ignored, so it just gets lost. The variable name still stores this original version. Okay, if I wanted to update the value of name, I'd have to create that new uppercase version and then reassign it back into my variable. So for any immutable object, invoking a method on that object is not going to change the object because you can't change the object, it's immutable. But what that's going to do is it's going to give you a brand new object, and then you can decide what you want to do with that object. Do you want to store it in a new variable? Do you want to store it back in the original variable? Do you want to print it out or pass it to a method or whatever it is you want to do? So keep that in mind that most of these classes we're going to be dealing with are immutable. Now again, there's some method naming conventions in these classes within the java.time package, and you can take a look. This chart is taken from this website here, but the methods that start with of, from, and parse, for example, these are static factory methods. So these are static methods that you can use to create instances of various objects. And then there are other methods, format, get, is, with, plus, minus, to, and at, methods that will start with this prefix that do certain things. So you can take a look at this chart. It's good to kind of keep this in mind. There's very standard naming conventions within this package, which is part of what makes it so user-friendly. Once you get used to these naming conventions, you can pretty much figure out what method it is you need based on what you need to do. So let's begin by looking at some of the classes. So the first one we're going to look at is local date. Now a local date or a local time, it's a date or a time with no associated time zone information. So for example, April 7th, 2016 is a local date. That would be different from a zoned date or a zoned time, which had a time zone information, which might be April 7th, 2016 at, 1800 hours Pacific Standard Time. So for local dates, you can kind of think about that like looking at the calendar on the wall. What is the date where I am right now? Right? It's not saying some absolute date at a specific time zone, but it's saying just a date or a time, basically like you're looking at the calendar, what date is circled there. Okay. Now, it is recommended to use local dates unless you really need to represent an absolute instance of time. So if what you truly need is one specific date or one specific, instant moment based on a time zone, then you should use time zone targeted classes. We're not going to go over those in this video, but you're welcome to look into that a little more on your own. But unless that's truly what you need, you should just be using the local date style classes in your programs. So local date is a class. A local date object is described by a year, a month, and a day of the month. And there are static methods now and of that are used to create local date objects. So for example, I can say local date today equals local date.now. That will create a new local date object based on the current date, and I can store it in my variable. I can use the .of method, so I can create a local date object with this year, this month, and this date. So this will give me March 17th, 2016. Or I can I can also use that of method, but sending in, so this one here, this version, you're allowed to pass in numeric parameters, so numbers to represent the month and the day, but you can also pass in enum values. So I could also say, month.July. Okay, so we can take a look at local date and you'll see those different options. And again, once you kind of get the hang of these methods, you're going to notice the repetitiveness of them once you start to get the hang of these classes. So again, if I take a look at the of method here, I can again create it with an int month and int, or an int enum and int. So two different ways to do that depending on how you want to do it. And yeah, I thought my slide had a typo there. July should be in all caps, but I will fix that. So a couple different ways that you can create local date objects. Now, how can you change a local date if you want to? Well, of course you can't, because they're immutable. But what you can do is you can invoke a method on a local date object that will create an entirely new object that is modified in some way, is a modification in some way of your current object. So some methods that are in the local date class to allow you to create these new objects would be plus days and plus weeks, minus days, minus weeks, plus months, plus years, minus months, minus years. So lots of these plus and minus methods where you just pass in the number of, days, weeks, months, years, whatever it is that you want to change your local date by. Now, again, this isn't going to change your current object because you can't do that, but it's going to give you a brand new object based on that specification, and you can then decide what to do with that. You can store it back in the original variable, which will essentially overwrite that variable, or you can put it in a new variable. There are also some plus and minus methods that you can pass in a duration or a certain number of chrono units. We're going to look at chrono units in a moment and also durations in a moment. So just keep this in the back of your mind. There's also some other helpful methods like is before and is after, where you can compare two local dates. Is it a leap year or until some other local date? So you can say, how long until a particular date, and that'll return to you a period object. We're going to talk about those as well. So let's first start up with duration. A duration is a time-based amount of time. So durations are described in nanoseconds, seconds, minutes, hours, and days, considering a day as a 24-hour period. And again, you'll notice this of, or of seconds. These are ways that we can create a duration. So one duration might be the duration of 6 hours. And here you'll see that chrono unit pop up again. We're going to look at that in a minute. So this would be the duration representing 6 hours, or this would be the duration representing 3 hours, and I can use the of hours method. This would be the duration of 30 seconds. And then if I wanted to know for this duration, if I wanted to pull out how many hours that was, once I had a duration object, I can use get, and I can send in what unit I'm looking for. So I have some duration and I want to know how many seconds is it or how many minutes is it. I can pull that out with the get method, passing in that chrono unit object to say, okay, what kind of unit am I trying to extract here? So again, durations represent this time-based amount of time, and you'll start to, again, notice the patterns in these naming of classes and methods. So let's just pull up duration real quick. Looks like there we go. So here you'll see some description, and then you can see you can get the number of hours, minutes, seconds out of a particular duration, or you can get, the particular, or it's just the get, that must be inherited from somewhere else. You can just get the particular unit that you're looking for, or you can, is longer than, is set. So there's all these different, is shorter than, all these different things you can use to apply to a duration. So now let's talk about chrono unit. Chrono unit is a class that's meant to represent the different units of date and time. So here are some of it's an enum, and here are some of the constants. It starts centuries, days, hours, minutes, months, seconds. Okay, so they're displayed over here. So forever, which is one of my favorite chrono units. So this represents all the different kind of units of date and time that you can ask for. So whenever you see a method that asks for a chrono unit or something, or a code that requires a chrono unit or returns a chrono unit, this is what they're talking about. They're talking about basically what kind of unit of time or what unit of a date are you talking about. So if we, so before moving backwards for a moment to look at how we've used those chrono units previously, there are some methods in the chrono unit enum that allow you to do things. Like there is a between method, for example. So you can say chrono unit some value dot between and give 2 moments, and it will tell you how many of those units are between those 2 moments. So for example, if I have a local date 1 and a local date 2, and I invoke this enum method, so I can say chrono unit dot days, so that's a enum value, dot between, and I give the 2 local dates, it'll tell me the number of days, because this is the unit I want and I'm asking for between. It'll tell me the number of days between these 2. If I wanted to know the number of seconds between 2 instants, I can do this. I can again invoke the chrono unit dot seconds, that's the value, and then on that value I invoke the method between, and that'll tell me the number of seconds in between these 2 instants. So in addition to those chrono unit constants, there's also that method that is really useful. Now let's go back for a moment. So you can see here that when we looked at local dates, you can say, +1 chrono unit dot weeks, or -1 chrono unit dot month, or however you want to change, quote, change that local date. And here too, we had chrono unit dot hours to represent that we were trying to extract out the hours from that duration. Now, one thing you have to be super careful with chrono units is that not all chrono units are supported by all types. So for example, instant objects, which we'll talk about momentarily, don't support chrono unit dot years. Period objects, on the other hand, don't support chrono unit dot seconds. These will be, if you try to use these in combination with the methods in the instant class or the period class, you will get a runtime error. Unfortunately, it's not a compiler error, it's a runtime error. So you have to be really, really careful that you're using a chrono unit that is supported by your particular class. So period, for example, a period is a date-based amount of time values. So this is in years, months, and days. So previously we looked at duration. This is time-based in, seconds, minutes, hours, and days. Period is kind of like longer stretches. It's date-based in days, months, or years. You can create these objects in the similar way we've been seeing. You can create a period of a certain number of years, months, and days. Or you can say period dot of days or of months or of years, or you can extract out the years from a particular period, for example, or the days from a particular period. So duration is, again, time-based stretches of time. Period is date-based stretches of dates. An instant is a particular point on a timeline. Instants are very good to be used for timestamps. So for example, instant right now, you can just say instant.now. That's similar to, we saw that before in local date.now. So for example, if you want to figure out how long your code takes to run, you can create an instant at the start, then run all your code, then create an instant at the end, and then you can use the dot between method of the duration class to see how much time has elapsed. So you can say the time elapsed is going to be the duration dot between the start and the end. And now this gives you a duration object, but what we really want to know is maybe how many minutes, how many seconds. So you can pull that out with the get seconds and the 2 minutes, for example. Changing instance and durations, again, you can't because they're immutable, but you can invoke methods to create these entirely new objects, which you can then perhaps overwrite the old variable or store in a new variable. Some of the useful methods are plus a certain number of seconds, or plus a certain number of minutes, minus a certain number of days, and so on, depending with whether you're dealing with instance or durations or periods. So again, if you wanted to take the current time and find out, create an instant a minute from then, this is how you could do that. So we talked about local date. There's a kind of parallel similar class, local time. So local date, remember, had a year, month, and day. Local time has an hour, minute, and second. And again, it's local because it's not zoned. So just like local date, you can think about as if you're just looking at the calendar on the wall, wherever you are. Local time, you can think about just looking at the clock from wherever you are. So, it's 4 o'clock, 4:30, whatever, in that wherever you are. It's not a particular 4:23 p.m. in a certain time zone. It's, just 4:30. Okay. There are similar methods in local time as there were in local date. There's the dot now and there's the dot of, that you can create a certain time at a certain hour and minute. You can either include the second or you can exclude it. So this would mean, at 6:10 p.m. Again, can't change local times, they're immutable, but you can invoke methods to create new objects, like you can add on a certain number of hours or minutes or seconds, or you can send in a duration to increase it by, or send in a duration to decrease it by. There's also, again, an is before and an is after, just like we had in local date. Now we've got local time and local date, and then we also have a local date time. And this is basically just a class that stores the date and the time together. So if all you care about is the date, the year, month, and day, you'd use local date. If all you care about is the time, meaning the hour, minute, and second, you'd use local time. But if you care about both those things, the year, the month, the day, the hour, the minute, the second, you just use local date time. And all the methods and usage are basically exactly parallel to these other two classes we looked at. It just kind of combines them both. We have some enums, one of which we looked at already. So we have day of the week enums, go Monday through Sunday, numeric valued 1 through 7. We've got the months, which go 1 through 12. We have within those enums, there's get display name, and you can send in different styles of how you want to display it. So you can kind of look at the methods that are given in those enums that make them a little bit user-friendly to use. Now, we can also parse and format our dates to and from strings. So if we have a string and we want to parse that string into a date object, well, the local date class, for example, can parse strings in this format, the 4-digit year dash 2-digit month dash 2-digit day. That's the particular date formatter called this here, the ISO local date. So for example, we could say local date, some date object gets local date.parse, and this will create a local date object that represents 2016, April 7th, 2016. Local time, similarly, can parse strings that are in this format. So if you wanted to create a time object that represents 6:10 p.m., you just say local time.parse and you put this in that format, and that can again be with or without the seconds, and that'll create that time object. Now, if you don't have things in these particular formats, you can create your own formatter to specify different formatting. So you can create a formatter by invoking datetime_formatter.of pattern, and then give your particular pattern, and then use that to parse a string. So these are super, super user-friendly ways to go from strings to date objects or strings to time objects with very little effort. This is something that was not so easy before. So this allows us to go from a string to a date, and of course we can go the other way around. If we want to display our date or time object in a particular way, we can again create a date time formatter object with whatever pattern we want, and then we just invoke on our date or time object, we invoke .format, and we pass that formatter along as a parameter, and that will give us a string of that date or time object formatted in that particular format. Now, this is a very small screen print, but it's listed on the API page of all the different formatting codes. So for example, I had some some L's in there before. The L is the month of the year in a certain format. So, and then lowercase d or uppercase d, the day of the year or the day of the month. The capital Y would be a week-based year. So you can kind of play around with these formats. And once you sort of use them a little bit, you kind of get the hang of how they work. So for example, as I showed here before, this would be the 3-character month, abbreviation for the month, and then the 2-digit day and the 4-digit year. Okay, the number of times you put these kind of pattern codes next to each other is really the number is usually the number that will show up. So this will be a 2-digit date, this will be a 4-digit year, for example. So let's just take a look at examples of this, because sometimes when you first see these classes, they seem very overwhelming because you kind of have to talk about them and learn about them all at once. Like, it's kind of hard to talk about one class and show you an example because all the classes intertwine together so much. So that's why I like to do a full overview of all the classes and then go through an example. But because I do that, the full overview of all the classes first, it kind of can be a little overwhelming at times. So just bear with me, because I think that after you get an opportunity to use these classes, you will see how user-friendly and kind of intuitive they are. And again, once you figure out the patterns of method naming and how things work, it's really very user-friendly. So we're going to look at an example. We're just going to create some objects and change some things about those objects. And then you can also take this code and kind of play around with it and experiment some more with your with these classes. So we're going to start by creating a local date. We're just going to print it out. You can see how it prints without being formatted. Then we're going to create a date time formatter, and we're going to use this pattern here, and we'll see what that looks like. And then we'll print out the today date formatted in that way. So when we run this program, you'll see that the come on, Eclipse. There we go. So this is the default formatting for a local date. It's the 4-digit year dash the 2-digit month dash the 2-digit day. And this is how I decided to print it out. So the 4 capital M's means the full written out month. And then I have the 2-digit day, a comma, and the 4-digit year. So that's how it prints out after I format it. Okay, so there's an example of creating a local date and formatting it for output. Now let's quote modify that date. Remember, you can't modify that date, but we can invoke a method to create a new date, and we can then take that new date and assign it to a particular variable, whether it's the same variable or a new variable. So I'm going to be using this today, which we can see here is September 26th, and I'm going to say, I'm going to print that out, and oh, sorry, before I do that, I'm going to invoke the plus method. So I'm going to take today and I'm going to add on 1 day. So this plus method takes the number of units you're adding and what unit you're adding. So I'm adding 1 day to this date here. And I'm going to store that back in a local date object that I'm calling tomorrow, because it's 1 day from today. And then I'll print those out. So you'll notice that today hasn't changed. It's still September 26th. Tomorrow, though, is September 27th. If I had wanted to update the actual value of today, I'd have to take this code here and then take that return value and store it back into today. That's the only way to update what a variable reference points to, is to assign it to a whole new object, because you can't change the object itself. Let's look at some more examples of using and creating some local dates. So here we're going to use the of method. So I'm going to say, okay, the local date of the year 2019, April 1st. So here I'm using that month enum, and that's going to be the local date object representing the next April Fool's Day. Then I want to know how far is it from now to then. So when's the next time there's going to be April Fool's Day? So I can use the period class and the static between method. So I can say period dot between today, that's a local date, and April Fool's, also a local date. So then I'll print that out. Time to fool, you can see how a period prints out without any formatting. And then I can say, okay, so that's what if I just want to know how many days that is? Well, April Fool's Day is in, and then I'm going to get the number of days. So get this unit, days. So let's print these out. So this is how the period prints out. Not very helpful. But April Fool's Day, it says, is in 6 days. Now, today is September 26th. April Fool's Day is in April. How is that 6 days away? Well, one other very important thing to know about this get method that I didn't talk about yet is that it kind of only gives you the leftover. So again, a period represents year, month, and day, right? So you can kind of think about if we're talking about dividing that up, you'll take however many years it is and then only take the amount of date time that's left, divvy that up into however many months they are, and then only take the time that's left and then divvy that up into the days. So it's kind of like a remainder or a modulus. So April Fool's Day obviously isn't in 6 days, but it's in some number of months plus an extra 6 days. Okay, so you got to be really careful about that. So if we really wanted to use that get method, what we could do to get the right answer is we can say this, time to fool.get, and we can first extract the months and then extract the days. And this will tell us, oh, it's in 6 months and 6 days. But if we really just wanted to know the number of days in total without kind of parsing out the months first, there's another way we can do that, and we can do that by invoking the between method. We can say chronounit.days, so that's the enum that represents that unit of time, days, and I want to know how many days are there between these two local dates. And that will tell me there are 187 days. So you got to keep in mind the difference between these things. If you're just using the get method with a chrono unit, you're just extracting kind of the leftover amount of date that is associated with that unit. Similarly, for if you're using local time, same thing. If you want to know the total number of that unit and you don't want just the leftover, then you want to use the between method through that chrono unit enum val. Okay? So let's look at some more methods. So here we're going to look at some formatting. So we're going to create a string that represents a date, and I'm going to create another date time formatter with this pattern. So I've got the two-digit month, which is represented with capital L, and then a dash, the 2-digit day, a dash, and the 4-digit year. I'm going to take the static parse method of local date, and I'm going to parse this particular string using this particular formatter. And then I'm going to save that back to a local date object. So again, this is the easy way to go from a string into a local date object. Then I'm going to use that isAfter method to tell me if today, that object we had from before, is after or before. And I can use that to print this line here. And then if I want to know how many days it is from now till then, I can use this date dot minus however many days. Sorry, misspoke there. If I want a date that represents I was trapped back in what we were doing before. If I want a date that represents the day before the midterm election eve, I can say the minus 1 day. So this gives me a new local date object that is 1 day earlier than midterms. So let's run this. So here we'll see the midterm election has not already happened because this already happened is going to be false. Today is not after that. And there will be lots of campaigning on November 5th. So this midterm date was November 6th. We then subtracted 1 day and we get November 5th. And again, we're using this time that formatter that I had at the beginning of this file for this output format there. I could format that instead using my input formatter, and it'll just print out differently. It'll just print out that 11-05-2018, which just so happens to be my birthday. Anyhow, okay, we're talking about birthdays. Let's take a look at a couple more methods here. So we're going to have here a string that represents a date. We're going to use that same input formatter to create a local date object. And now let's say we want the local date that represents the birthday of this current year. So this birth date was in 2014. And let's say now I want the same birthday, June 8th, but I want it in this year. So what I can do is I can say, give me a local date that represents the current year, which you can get by saying local date.now.getYear. But then I want the month and day from this birthday object. So I can say birthday date got get month and birthday date got birthday date dot get day of month. So I'm extracting the year from the current local date, the now time, and then the month and the day from this other object. Then I can determine if that's already happened using the is after. So for example, the birthday has already happened because it's September, and so June 8th of 2018 is in the past, it's already happened. Now, if I want to kind of figure out, again, some timing of in between dates, I can create a number of days of life, let's say between the birthday date, which was June 8th, 2014, and today. That will give me a period. Remember, durations represent spans of minutes, hours, seconds. Periods represent spans of years, months, days. So this is going to give me the period of time between the birth date in 2014 and today. And then I can print that out by invoking the getDays method. And it's going to tell me that there have been 18 days since birth. Again, getDays, just like we saw similarly earlier, is going to give you those kind of leftover days. So it's going to parse out the total number of years. What's ever left over, it's going to parse that into months. What's ever left over, that's going to be getDays. So if I really want the answer, there are two ways I can do it. I can either separate out the days between. I can separate out, I could say, get year, life days dot get years plus life days dot get months plus, and concatenate all that together. Or I can use the chronodate dot days between and then send in the two dates. So there we go, and that gives you the full complete number of days. I believe there's also, sorry, I should add this example here. There is a way to invoke that on the period as well. I think it's days, I can't remember which method, but I'll add that here. One other thing I wanted to show you is, let's say we want to know, oh, well, how many seconds has there been from this birth date to today? Okay, so there's another chrono unit, right? How many seconds between this date and this date? If I run that, it's going to crash, and it's going to tell me unsupported temporal type exception. Seconds is not supported by local date. Okay, so this is an example of what I was showing you, that certain chrono units are not represented or supported in certain classes. But it's not a compile time error, right? I was able to compile this code just fine. It's a runtime error, so it's going to crash when I actually run it. All right, one last example is using instants to time your program. So here I'm going to create a instant, then I'm just going to put the program to sleep for 3 seconds, create another instant, and then find the duration between them, print out the seconds in 2 different ways, which should print out as 3. There we go. Okay, so 2 different ways to get that information. Similarly to the example we saw a moment ago, let's say I want to know how many years are between those 2 instants. That's going to crash because the chrono unit of years is not supported in the instant class. So again, you do have to kind of keep in mind whether you're dealing with sort of these minutes, seconds, hours type measurement or days, months, years type measurement, and kind of keep them separated because they do support different functionality. So there is your kind of brief overview of all the date and time classes, but hopefully walking through this example kind of gave you a sense of how to use these classes. I really encourage you to play around with this example, kind of experiment with the different methods. I think once you use these classes a little bit, they really do become incredibly intuitive to use. They can be a little overwhelming at first because, again, you kind of have to look at them in their totality before you can use them because they are all so intertwined. But once you start to use them, you kind of can pretty quickly get the hang of it, and hopefully you'll find them very user-friendly because that is what they are designed to be.